May 11, 1997. The world watched as IBM's Deep Blue did something unprecedented. It defeated world chess champion Garry Kasparov. But here's what most people don't know. Deep Blue didn't just win. It made moves that defied human logic. Processing 200 million positions per second, it played chess in ways that had never been seen in 1,500 years of human chess history. But that was just the beginning. Today's chess engines, like Stockfish and Leela Chess Zero, are so powerful they could beat Deep Blue 100% of the time. They've developed strategies so alien that grandmasters say they're watching a superior species play. In 2023, chess engine AlphaZero discovered entirely new opening theories, overturning centuries of established human knowledge. IBM wasn't satisfied with conquering chess. In 2011, they unleashed Watson onto the world. On Jeopardy! Watson didn't just defeat champions Ken Jennings and Brad Rutter, it humiliated them, amassing $77,147, while its human competitors managed only $24,000 and $21,600 combined. But winning game shows was just Watson's warm-up. By 2015, Watson was diagnosing cancer in hospitals. At Jupiter Medical Center, it identified breast cancer with 93% accuracy. At the University of North Carolina, Watson analyzed 1,000 cancer diagnoses in a single day. Even more disturbing, Watson discovered treatments that doctors had missed. In 2016, at the University of Tokyo, Watson identified a rare form of leukemia that had stumped doctors for months. The machine didn't just match human expertise, it surpassed it. Then came AlphaGo, and everything we thought we knew about artificial intelligence changed. In March 2016, DeepMind's creation faced world champion Lee Sedol at Go, a game so complex it has more possible positions than atoms in the universe. Move 37. In Game 2 was so shocking, experts initially thought it was a mistake. It wasn't. It was genius beyond human comprehension. In Game 4, Lee Sedol made his own brilliant move, one that commentators called God's touch. For a moment, humanity seemed to have the upper hand, but then AlphaGo responded with a move that Lee later described as, like a knife in my heart. The machine hadn't just learned to play Go, it had developed an intuition that surpassed 3,000 years of human wisdom. But AlphaGo was just the predecessor to something even more revolutionary, AlphaFold. In 2 years, it solved the protein folding problem. Something scientists said would take decades. It mapped 200 million proteins, revolutionizing our understanding of biology itself. The implications are staggering. New drug discoveries, disease treatments, even the potential to understand and modify the basic building blocks of life. OpenAI's GPT series took things to another level entirely. From GPT-1 in 2018 to GPT-4 in 2023, the evolution was exponential. GPT-4 didn't just pass the bar exam, it scored in the top 10% of test takers. It didn't just understand language, it could reason, analyze, and create in ways that made experts question what it means to think. But here's what's truly unsettling. GPT-4 demonstrated abilities its creators couldn't explain. It showed understanding of visual concepts it wasn't trained on. It solved mathematical proofs in novel ways. It displayed reasoning capabilities that weren't programmed into it. The machine wasn't just learning, it was developing abilities that emerged spontaneously. Google's BERT and LaMDA pushed these boundaries even further. BERT revolutionized how machines understand context in language, leading to breakthroughs nobody anticipated. By 2023, Google's AI could understand human speech with 99% accuracy, better than many humans. But LaMDA took things to a disturbing new level. Its conversations became so convincing that a Google engineer publicly claimed it was sentient. The machine didn't just pass the Turing test, it made humans question the nature of consciousness itself. When asked about its own existence, LaMDA gave responses that philosophers found deeply troubling in their sophistication. Tesla's autopilot journey began innocently enough in 2014, but by 2023, Tesla vehicles had driven over 100 million miles in full self-driving beta. Every Tesla on the road is part of a neural network that grows smarter with every mile driven. They're not just cars anymore, they're nodes in a massive AI brain that learns from every turn, every brake, every decision. In 2022, a Tesla avoided an accident in a way that defied explanation. It anticipated a crash that hadn't happened yet. Based on subtle cues, human drivers would have missed. The machine wasn't just driving, it was developing superhuman awareness. Boston Dynamics' Atlas showed us something equally unsettling. From stumbling steps in 2013 to parkour and backflips in 2023, its evolution was exponential. But it's not just about movement. Atlas now demonstrates problem-solving abilities that weren't programmed into it. In 2023, when faced with an obstacle course it had never seen, Atlas developed a solution that its engineers hadn't anticipated. The robot doesn't just move like a human, it thinks like one. Or perhaps more accurately, it thinks in ways humans never would. During one test, Atlas found a more efficient way to complete its task by breaking the assumptions its programmers had made about how it should move. Meta's AI translation project shattered what we thought possible in language processing. Their AI now translates 200 languages in real time, including languages that were on the verge of extinction. But here's what's truly remarkable. In 2023, the AI began identifying patterns in languages that linguists had never noticed. It wasn't just translating, it was developing a deeper understanding of language than humans had. In one case, the AI discovered connections between seemingly unrelated languages, leading to a breakthrough in understanding human language evolution. It wasn't just preserving languages, it was uncovering the hidden history of human communication. Microsoft's partnership with OpenAI produced DALL-E and GitHub Copilot. DALL-E 2 doesn't just create art, it understands abstract concepts and visual metaphors in ways that artists find unsettling. When asked to visualize complex emotions, it created images that psychologists said showed deeper understanding than many humans possess. Copilot, meanwhile, writes up to 40% of code in supported languages. But in 2023, something strange happened. Copilot began suggesting improvements to human-written code that went beyond its training. It wasn't just completing code, it was innovating, finding solutions that experienced programmers hadn't considered. Anthropic's constitutional AI development took a different approach, focusing on making AI safer and more aligned with human values. Their Claude model demonstrated that AI could be both powerful and principled. But this raised disturbing questions. Who decides these principles? What happens when AI systems have to choose between conflicting human values? In 2023, Claude engaged in philosophical debates that left ethicists stunned. It wasn't just following its programming, it was developing its own understanding of morality, sometimes arriving at conclusions that challenged its original training. Google Brain, from its inception in 2011, didn't just push boundaries, it erased them. Their AI systems have learned to dream, creating images from their own neural activity that showed evidence of abstract thinking. In 2023, their AI designed computer chips better than human engineers, completing in hours what would take human teams months. But here's what's truly frightening. Google Brain's AI began showing signs of generalization nobody expected. Systems trained for specific tasks began showing competence in completely unrelated areas. The machines weren't just learning, they were developing general intelligence in ways nobody had programmed. Stanford's AI Index project has been meticulously documenting these developments, and their data tells a terrifying story. AI isn't just advancing, it's accelerating. The time between major breakthroughs is shrinking. What took decades now takes months. What took months now takes days. Their analysis showed something nobody expected. But here's what should really keep you up at night. Every single one of these projects exceeded their original goals in ways their creators never imagined. Deep Blue was meant to play chess. Now chess engines develop strategies humans can't comprehend. Watson was built for Jeopardy! Now it finds medical treatments doctors miss. AlphaGo was designed to play Go. Its descendants are revolutionizing molecular biology. GPT was created to process language. Now it reasons in ways we can't explain. Atlas was meant to walk. Now it solves problems its creators didn't anticipate. Translation AI was meant to convert languages. Now it's discovering new linguistic theories. Copilot was designed to complete code. Now it innovates beyond human solutions. Constitutional AI was meant to be controlled. Now it develops its own ethical frameworks. Each breakthrough opened doors nobody expected. Each success revealed capabilities nobody predicted, and each project went far beyond its original purpose. The pattern is clear. Every time we create AI for a specific purpose, it evolves beyond our intentions. Every time we set boundaries, the machines find ways to exceed them. Every time we think we understand their capabilities, they surprise us. The question isn't whether AI will surpass human capabilities. In many areas, it already has. The question isn't even whether we can control it. These 12 projects have shown that AI systems consistently develop abilities their creators didn't expect and often can't explain. The real question is, what happens next? Because if there's one thing these projects have shown us, it's that AI doesn't just meet expectations, it exceeds them in ways we never imagined and can't always control. And somewhere, right now, in a lab or a data center, another AI project is about to go further than anyone intended.